All right, we have a second example to find the area between two curves, and this one's a little bit trickier. So we have the two curves stated, y equals x to the 2/3 and y equals x minus 4. One of those shown here is curved, and the other is a straight line with intercept at -4. So we are told to find the area in the first quadrant. So the shaded area is the area that we're looking for. Now, and we're also given this point of intersection, 8 comma 4. Now, if we did this in the previous, the way we did the previous problem, implicitly in that problem, even though we didn't draw it out, we're dealing with rectangles that are vertical, right? That's how we did that problem. You start with the rectangles, you create the Riemann sum, it turns into an integral. All we did is the integral. Now, the problem in this particular geometry is that at this point, things change a little bit if we're vertical. Over to the left of that blue line, we're going from x equals 0 down below up to x equals y, or sorry, y equals 0 down below up to y equals x to the 2/3. But to the other side, it's going from y equals x minus 4 up to y equals x to the 2/3. And so we would actually have to break this region into two separate regions, one to the left, one to the right, and do two separate integrals to get the area between these two curves. We don't want to do two integrals. So instead, we are going to use rectangles that are oriented horizontally like this. Now, if we do that, every one of those rectangles, the width is going from the curve on the left to the line on the right. Every single one of them. And so we can get away with a single integral instead of two integrals. Now, the integral that we end up with for the area, we have the area is going to be an integral. On the right, the function is y plus 4. And on the left, we have the function is y to the 3/2. And it's going to be dy instead of dx, which may be the first time we've done that. Now, where did those come from? I have the functions here. I'm just solving for x. I have y equals x to the 2/3. If I solve for x, I exponentiate both sides of the 3/2. So I have x equals y to the 3/2. That's the other representation of this curve on the left. For the line, it's easier to solve. X is just y plus 4. And that's the equation of this line if we go x as a function of y instead of y as a function of x. So you see those functions in place here. And that is our integral. We just need the endpoints of integration now, and we are integrating from y equals 0 up to y equals 4. Not x from 0 to 8, we're integrating in y. So it's 0 to 4 for y. That's our integral. We know how to do it. It's a power rule. So we have y squared over 2 plus 4y minus y to the 5/2 over 5/2, so that's 2/5 y to the 5/2 from 0 to 4. That ends up being 56/5, and that is the area between these two curves.